Oil drills don't go looking for history. They go looking for money. The entire operation, the crew, the machinery, the miles of steel pipe exists to punch a hole in the earth and pull out something valuable. What nobody plans for is what happens when the hole punches back. Number 10. The Kola Super Deep Borehole. The opening is 23 centimeters wide, roughly the diameter of a dinner plate. It goes down 12 kilometers. Soviet engineers began drilling in 1970 on the Kola Peninsula, purely to see how deep human machinery could go. For 19 years, they kept going. Almost nothing they found matched what the textbook said should be there. The first shock was heat. They predicted around 100 degrees Celsius at the bottom. They got 180. At that temperature, the rock stopped behaving like rock. It became plastic, slow and yielding, and began flowing back into the hole. The drill would push down, and the earth would quietly seal itself shut behind it. The second shock came from the cores. At 6 kilometers down, in granite nearly 2 billion years old, they found microfossils, 24 species of ancient plankton, preserved in stone that had spent 2 billion years buried under kilometers of crust. They should not have survived. They did. The project was abandoned when the Soviet Union collapsed. Engineers welded a metal cap over the hole. It's still there, a rusted disc the size of a manhole cover, in the Arctic, sealing the deepest wound humanity has ever made in the planet. They reached 1/3 of the way through the continental crust. The mantle stayed completely out of reach. Number 9. The Nodosaur. On March 21st, 2011, a shovel operator named Sean Funk was working a routine shift at the Suncor oil sands mine in Alberta. His machine hit something that wasn't rock. What came out of the ground is now kept at the Royal Tyrrell Museum. It weighs 1,300 kilograms. It is 110 million years old, and it looks like it died last week. The animal is a nodosaur, an armored plant eater from the early Cretaceous. Most dinosaurs survive as scattered bones. This one came out with its skin intact, its armored plates still attached, its three-dimensional body shape preserved. Technician Mark Mitchell spent 7,000 hours freeing it from the rock. Researchers extracted preserved melanin and reconstructed the animal's coloring, reddish-brown, with countershading, darker on top, lighter underneath. Countershading is a camouflage strategy used by prey animals. An armored creature weighing over a ton still needed to hide from something. The stomach contents survived, fern leaves. The chemistry of the plants allowed scientists to narrow the time of death to late spring or early summer. The oil sands mine was digging through a Cretaceous seabed. The animal had floated out to sea after death, sank, landed in soft marine sediment, and been mineralized so quickly the soft tissue never had time to rot. It waited 110 million years until a mining operation punched through the ceiling of its grave. Number 8. Lucy. On May 29, 2006, the ground near Sidoarjo in East Java started bleeding mud. It came from a gas exploration well. What began as a seep became a torrent. At its peak, 180,000 cubic meters of hot mud per day. The mud buried at least 12 villages. Around 40,000 people were displaced. Engineers dropped chains of concrete balls into the vent to choke it. The vent ignored them. The material coming out was ancient, pressurized marine clay from the Pliocene, up to 5 million years old, sealed underground until the drill gave it somewhere to go. It came up near boiling, carrying microfossils from a seafloor that hadn't seen daylight in millions of years. Whether the well caused the eruption or a magnitude 6.3 earthquake 2 days earlier was responsible is still debated. When petroleum geologists voted on the question at a 2008 conference, the majority pointed at the drilling. The company disputed it. Courts became involved. No one has been held legally responsible for what the ground is still doing. Lucy has been erupting for 18 years. Some estimates suggest it may continue for another decade. The villages underneath are gone. The mud keeps coming. Number 7. Ekofisk. They built platforms on the North Sea. Then they had to jack the platforms up 6 meters because the seafloor was sinking. Phillips Petroleum discovered the Ekofisk field in 1969 and began extracting oil and gas from a reservoir deep in the chalk beneath the seabed, under a microscope. That chalk resolves into something else. Billions of microscopic calcium carbonate plates, each shed by a single-celled algae called a coccolithophore when it died, 60 to 70 million years ago. The reservoir is a compressed graveyard of Cretaceous plankton. The oil moves through their bones, Chalk is porous, which made it a good reservoir and also made it fragile. As pressure dropped, the chalk compacted, the seabed began to sink. Eventually, by around 9 meters over the field's life, the platforms had to be physically raised to stay above the waves. Coccolithophores are not extinct. Their blooms turn the sea a milky turquoise visible from space. Every barrel extracted at Ekofisk passes through the remains of organisms whose living relatives are still out there, still dying, still building the chalk of the distant future. Number 6. The Bertha Rogers Hole. At the bottom of a gas well in Elk City, Oklahoma, there is a lake. It is not made of water. In 1974, Lone Star Producing drilled the Bertha Rogers number 1 well to 9,583 meters, the deepest hole on Earth at the time, near the bottom. The drill struck a reservoir of molten elemental sulfur. Sulfur melts at around 115 degrees Celsius. The temperature at the bottom of the well was 246 degrees. Sealed in the dark at 9 kilometers down, there was a lake of liquid yellow rock. The drill bit pushed into it and was destroyed. The well never went deeper. The leading explanation involves thermochemical sulfate reduction. At extreme temperatures, sulfate minerals react with hydrocarbons and release elemental sulfur and hydrogen sulfide. At those temperatures, no biology is possible. The chemistry runs on heat alone. The well produced some natural gas. It was never the commercial success its record-breaking depth had promised. It stands instead as a monument to how hostile the deep earth becomes. Where the rock flows, the sulfur runs liquid, and the only thing the drill brought back up was proof that it could not go further. The deeper you go, the stranger the planet gets, and it only gets stranger from here. Number 5. Fire ice. They pulled a lump of ice from the seafloor. Someone held a flame to it. It burned. Methane hydrate forms when methane gets trapped inside a lattice of frozen water molecules under high pressure and low temperature. 1 cubic meter releases roughly 160 to 180 cubic meters of methane gas when it reaches the surface and falls apart. Drilling operations encounter it routinely, chunks that come up fizzing and dissolving before anyone can examine them properly. That instability is not just inconvenient, it is a drilling hazard. Sudden gas release from disturbed hydrate can surge up a borehole. Researchers have linked hydrate behavior in the riser pipe to events during the 2010 Deepwater Horizon disaster. The total carbon locked in methane hydrate deposits worldwide is estimated to exceed all other fossil fuel reserves combined. A large-scale release is suspected in the Paleocene-Eocene thermal maximum, around 56 million years ago, one of the sharpest warming events in the geological record. Methane is roughly 80 times more potent than carbon dioxide over a 20-year period. The deposits in Arctic permafrost are already destabilizing. Japan ran the first offshore production test in 2013. China extracted methane from hydrates in 2017 and again in 2020. The energy is there. So is everything else that comes with it. Number 4. Chicxulub. 66 million years ago, an asteroid 10 to 12 kilometers across hit the Yucatan Peninsula. In 2016, a drilling expedition went straight into the crater, co-led by Joanna Morgan of Imperial College London and Sean Gulick of the University of Texas. The team drilled from a lift boat in shallow Gulf water to 1,335 meters below the seafloor, targeting the Peak Ring, the circle of mountains inside the crater. The cores confirmed something that had only been theorized during the impact. Solid granite briefly behaved like a fluid. Rock from 10 kilometers deep hurled to the surface in minutes before freezing back into stone. 130 meters of core recorded the first hours after impact. Melt rock, shattered breccia, tsunami backwash. Charcoal from wildfires ignited across the region. The worst afternoon in the history of complex life, preserved in drill core. The detail that explains the extinction isn't in what the cores contain, it's in what's missing. The rocks should be rich in sulfur-bearing minerals. They're not. The impact vaporized them. Those sulfate aerosols spread through the upper atmosphere, reflected sunlight away, and collapsed food chains across the planet. Just above the impact layer, the cores show burrows, microfossils, life returning to ground zero within years to a few thousand years of the impact. The planet did not wait long to try again. Number 3. Sour gas. Nobody sees it first. They smell it. Hydrogen sulfide occurs naturally in reservoirs where sulfate minerals have reacted with hydrocarbons under heat and pressure over millions of years. Wells that contain it are called sour wells. At concentrations above a few hundred parts per million, hydrogen sulfide kills within minutes. At high concentrations, it paralyzes the olfactory nerve. You stop smelling it right before it kills you. The hydrogen sulfide in a sour gas field is the chemical residue of ancient marine life. Organisms from the Carboniferous, roughly 300 million years ago, sank into anoxic sediment, were buried, heated, compressed, and converted over geological time into hydrocarbons and sulfur compounds. The Lac gas field in France, one of the most significant sour finds in European history, had hydrogen sulfide content running as high as 15%. Every worker carried a gas mask. Standard steel corrodes in it. What came out of the ground smelled like death because 300 million years ago. That's exactly what it was. Number 2. The oldest water on Earth. She tasted it. That was the first thing Barbara Sherwood Lawler did after confirming what her team had found. She described it as extremely salty and bitter, far worse than seawater. That fits. The water flowing from fractures 2.9 kilometers down in the Canadian Shield had been sealed in that rock for roughly 2 billion years. 2 billion years of reacting with the surrounding stone left it up to 8 times saltier than the ocean. The dating uses noble gases dissolved in the water: helium, neon, argon, xenon, which accumulate in trapped water at a known rate as surrounding rock decays radioactively. Measure the ratios. Read the clock. Sherwood Lawler's team first published in 2013. A 2016 analysis from a deeper fracture pushed the number to 2 billion years. What keeps this from being merely a chemistry result is what the water sustains. It carries dissolved hydrogen, produced when radiation splits water molecules, a process called radiolysis. Sulfate-reducing microbes in the fractures use that hydrogen as food. With no sunlight, no photosynthesis, no connection to the surface whatsoever, they have been down there, in the dark, for longer than multicellular life has existed on this planet. Number 1. The bacteria that came back. The sample was sealed the moment it left the ground. The drill core was handled under sterile conditions. The team designed the protocol to answer the contamination objection before anyone raised it. In 2000, Russell Vreeland's team reported recovering a living bacterium from a microscopic pocket of brine trapped inside a salt crystal from the Salado Formation in New Mexico. The salt dated to the Permian, roughly 250 million years ago. The bacterium had survived as an endospore, a dormant, armored capsule that certain bacteria form when conditions become hostile, sealed inside a crystal with no food, no water, no light, and no chemical gradient to exploit. The criticism was immediate. The organism's DNA looked nearly identical to modern relatives. Over 250 million years, far more genetic drift should have accumulated. Either the sample was contaminated, or the salt had recrystallized more recently than the geology suggested. The debate was never fully resolved. What is not disputed is what the question implies: if it's real. A living organism sat inside a salt crystal for 250 million years and woke up when a drill disturbed the rock around it. The Salado Formation sits beneath a nuclear waste disposal site. The borehole was drilled to assess the geology for long-term containment, to find rock stable enough to bury something dangerous for a very long time. What they may have found instead was something that had already been doing exactly that.